Hi, my name is Daniel Salam, and today I'll be guiding you through this lab tutorial. This tutorial will be about the math script and the formula node. Let's first talk about the formula node. The formula node is a convenient text-based node used to perform mathematical operations on the block diagram. This is very useful for equations that were already written in a text-based code. The operations in this structure don't need to be placed in order since they all perform simultaneously. In the example below, we have y equals 5x, m equals z times y divided by 10, and z equals y minus 4. Even though z is gotten after the third operation, it can still be used as a variable for the second one since all operations are performed at the same time. Now let's talk about the math script. This structure brings mathematical-oriented textual programming to LabVIEW, which allows you to perform single or sequential mathematical operations. The set of mathematical operations below are performed in order, so if a result from an operation is needed to perform another one, then the operations must be placed in logical order, otherwise there will be an error. In the example below, the operations provide a simulation of a missile launch at different heights, both above and under the ground level, at different speeds, and at different angles. The values of the inputs for each variable are gotten from other controls that send the value to the input of the math script. The outputs represent the value gotten from each mathematical operation, and they are to the right of the structure, so which you can wire to another indicator in your block diagram. Let's now look at some examples. Okay, let's start by creating a formula node. To create one, you go to the block diagram, you right click, go to structures, and click on the formula node, click and then drag just as you would do with a while loop. Now let's create three inputs. You left click in the border, right click then, and click on add input. Let's call this one A. Let's add another two called B and C. Let's now add three outputs. Click, then right click and click on add output. Let's call them X, Y, and Q. Now that you have your variables, you will write your first equation, which is X equals A times C, and put a semicolon. Enter. Now Q equals Y times B, semicolon, enter, and then Y equals B times A, semicolon. Let's create our controllers. Let's now go to the front panel. We have our controllers and our indicators. And run the VI continuously. Change the values of your controllers and you see how the value of your indicators will change. X is equal to A times C, which is 2 times 3. You see how it changes? Now Q is equal to Y times B. you have y18 times b and you have y equals b times a, which is 3 and 6, 18. Now stop the BI and go to your block diagram. Let's say that we change this v for q. Even though this structure performs the operations simultaneously, if we have q equals y times b and y equals q times a, we have the same variable twice, and the formula node will not be able to get any value, so y and q will equal 0. Well, in this case was infinite, since it's creating a run state in which they get their values and they multiply each time they get them, and it will not stop since one gets the value of the other one and they're increasing simultaneously. Now x is 5 times 6, 30. Of course, if we get a value of, for example, 0, it'll be 0. Well, in this case, NaN. Say 1, same thing. So it basically will be some kind of error that you will not be able to get any exact value. Let's now create the math script. You right click in your block diagram, you go to structures, and you click on the math script node. Now you create inputs and outputs the same way you do with your formula node. Here in the bottom you have your inputs and outputs for your error clusters to monitor your errors, and let's create two inputs. They will be A and B. And three outputs, C, X, and Y. Let's now go to the front panel and see this figure here, in which we have that these two angles are Y and X. We have a right angle, so we have a right triangle, and these two sides will be A and B, and the hypotenuse is C. So we write the first equation, which is C, or hypotenuse, will be equal to the square root of A squared plus B squared and all of that is under the square root. And we put our semicolon and we click enter. We already have our value for C. To get X, we know that this angle, well, let's first create our controllers. This is A, B, C, X, and Y. Okay. Now we're placing so you can know exactly what I'm doing. A is this side of the triangle. This is B. And this is C. Of course, this is Y and X. Now, to get X, we'll get the cosine of b divided by c, and we will get the inverse of that. Since the MathScript node gets the value in radians, we will multiply that by 180 and divide it by pi. So we have that x is equal to, open parentheses, and again we write a cos, which is the inverse of the cosine. We write what we're dividing, which is b divided by c, close parentheses, multiply by 180, close parentheses, and divide by pi, and semicolon. Now we check the error, which says column 22 expecting R parent found. So we check again, and I'm missing one parenthesis, so we put another one after the first one that goes after the C, and the mistake has been corrected. Now to get the other angle, we copy the function, we put it in the third line, and we change the B for an A. Now we check for errors, and it says the output variable y is unknown. Oh, because we didn't put y equals in here. So now we can run the VI. So let's run it continuously. And we give the values of A3, B4, and we have 3, 4, 5. Now if I change this to 4, the angles should be the same, and they are. Now let's change this to, well, 0.5, and this is 0.83. And let's use 0.87. We should get something approximate to 60 and 30. I'm trying to write square root of 3 over 2, but you cannot write radicals. So now let's go to the block diagram, and let's change the order of these, well, actually this, to the second one. Oh, sorry. And we delete this, and we put this as x, change this to b. So now we're asking to get the cosine, but the first operation is to divide b by c, but we will have c in the second operation, so this should get an error when I run it. And it did. It says the given name does not correspond to a known function, variable or symbol. Line 1, C. Because I don't have C yet until the second operation runs. In this case, if I wanted to put the first operation as the operation to get the angle x, I should use the function tangent, since I wouldn't really need the value of C. And the same one for this. Actually not for this one, because it's the third one. So I would use, wait, where's x? So we'll have to use A divided by B. And that way I wouldn't have an error, since I'm using variables that I'll still have. And I'm not using values that I haven't gotten yet. If you want to see how it works, I turn highlight execution and click run. First one, first two, then the third one. And it finishes. This will conclude this tutorial. Thank you for watching.